Welcome to my YouTube channel. First, I want to say a big thank you to all of you who have subscribed, liked, and shared my previous video on linear regression model prediction. Today, we are going to dive into another important machine learning algorithm, which is logistic regression. Logistic regression is a machine learning algorithm used for classification tasks. If you have ever wondered how machines make yes or no decisions, like detecting spam emails or not, predicting if a customer will buy a product or not, or determining whether something is healthy or unhealthy, then this video is for you. Okay, this is the data set that we're going to use for this video today. Okay, it is a data set about diabetes. Okay, so as you can see, in this data set, we have the features of pregnancies, glucose, blood pressure, skin. I think this is skin thickness, insulin, BMI, diabetes pedigree function, age, as well as outcome. So as you can see, outcome 1 means diabetic and 0 means non-diabetic. So today what we are going to do, we are going to teach this machine learning to train them based on this data set from all these features as well as outcome. So next time when the doctor or the nurses, sorry, when the doctor or the nurses type in the features like pregnancy, glucose, blood pressure, skin thickness, etc., they will give the outcome whether the person is diabetic or non-diabetic. Alright, so I hope you understand what we're going to do today. And if you want this data set, it is listed in the description below. Just click on the link and you can download and make use of this data set and work together with me. So let's move on. Okay, I'm going to use Google Colab for this video because it's much faster and more productive. As you know that when we tap a little bit, it will just pop up certain things, right? So let's begin. First, I'm going to maybe upload the video, the CSV. Just by clicking here and let's wait. So when you click this folder, right, this will pops up. Just click on this. So I have this data set, I think inside my data. Yep, over here. And let's see which one is it. That's not IMH data. It is diabetes CSV. Yep. Okay, so I can just open it. Oh, lah, okay, just okay. And then once done, you can just click the text. Maybe I want to give everything has a comment, right? Maybe a title first, like importing. Oops, just spelled it incorrectly. Sorry about that. Importing all the maybe necessary, spell it correctly. Okay, all right, dependencies. Okay, so this is to tell us that these are the dependencies I need to import. Okay, DEPEN, dependencies. All right, great. So let's go to the code. Okay, so of course we need to import. This is a normal procedure before we start doing the coding for OOPS data analysis as well as data science project, right? So import, let's say pandas as PD, as you know that uh, pandas are important in terms of us to load the data, to showcase the, let's say the head and the tail of the data set and many more. Okay, and also import numpys, okay, numpy as NP, and this is good for array. It makes a little bit more faster comparing us, before time, like in Python. Before I know this number, I need to calculate between each array individually, and it takes a lot of time. Yeah, now we can just import libraries to make things much more easy and productive. Okay, so now because I'm not going to just visualize it, I am going to, in this in this tutorial of video, I'm going to do the prediction, right? So what I'm going to do, I'm going to use sklearn, which is basically what I'm going to do. Okay, if you notice this data set, yeah, I need to standardize certain of the features, right? Let's say the diabetes pedigree function, it is like 0 point something, but like glucose as well as blood pressure as well as insulin is all is not in decimal number, it's not in fluid, alright? And it even goes up to 846 comparing to this just like 0 0.1. Okay, 3134. It's very, very minimal. So I don't want like other features to be dominating, especially this insulin has a huge figure 846 comparing to just 0.134, for example, right? So I need to import I need to use the sklen to import this, okay, from sklen dot pre-processing, all right, dot pre-processing import standard scalar. Yep, it typed for me. Great. All right. So once I've done that, I also need to remember that we have to always train the data and also to test the data. So we have to split it. So we need this also from sklen. Yeah, they type it for me. Great. Right, mode selection, import, train, test, split. This is just to split the data in order for it to train as well as to test, okay, because it's important for us before giving the prediction. All right, we always have to train the model and to teach them, right? And then after training we have to test them, right? So SVM over here they are using support vector machine, which is good. It's very good for, especially in terms of dealing with binary data set, like predicting whether it's a 0 or 1. Okay, and another thing also, yeah, I think you can also, because we're going to use logistic regression, right? As I've mentioned just now, in the first part. Okay, we are going to use logistic regression, like predicting whether it's a 0 or 1, like predicting whether it's diabetic for 1 or non-diabetic for 0. Okay, great. So I leave it to do this, but SVM, I think I will also, maybe we can do two, okay? Algorithm. First is maybe logistic regression, because I'm doing this video for logistic regression purposes. Okay, so yep, I'm going to use sklearn linear model import logistic regression. Okay, this is something also we can use for another algorithm, and let's check later on which one has a better accuracy, whether just using logistic regression can give us a better accuracy or SVM, okay, support vector machine will give us a better accuracy. So we can do both, and let's see which one is better in terms of the score, and then we can make full use of it, okay? So yep, the next step after installing all the, importing all the dependency, maybe I will start doing the data collection. Okay, so data collection and the analysis. Okay, so without further ado, let's do the code. So definitely you have to load the data, right? So the data set mm, to append this data frame. Okay, so what I'm going to do, maybe I'm going to call this data set as a variable called, yeah, diabetes data set. Okay, great. So I'm going to call this data set a name for the dataset as diabetes dataset. Okay, this is the variable I'm going to create, and pd.read.csv based on the diabetes CSV file name that I have loaded here, imported here. Okay, so I just name it exactly as it is. Okay, now if I'm going to run this, it's not going to do anything definitely. Huh, there is an error. Maybe because I haven't run this. Alright, yeah, so I got to run this now. That should works. Okay, now next, what I'm going to do to see at least the first 5 rows of the data set, right? So let me just comment this, like printing the first 5 rows uh, of the data set, okay? Of the data set. So what I'm going to do is that I just go call upon this diabetes data set again. Yep, oops. Okay, over here, diabetes, oops, diabetes, yeah, it's a bit for me, great. Alright, and dot head. Okay, and let's see. Did I spell it correctly? Diabetes, Betes. Oh, I forget the underscore data set. It has to be exactly what I have named here. Yeah. It's not CSV. It's just diabetes data set and dot hit. Alright, so let's run now. That should work. Alright, so it gives me the first five um you know the first five columns of this data set, yeah, with all the other nine, one, two, three, four. I think there's nine. Didn't really indicate here, never mind. Let's try to do the shape so that I can know how many actually columns they have and how many rows they have, right? For example, this data set in Excel, I don't bother to browse all the way down. Maybe you can see it from here also. It's not written. It's not written, yeah. Hmm. Okay, so let me click something and see whether it writes. Yeah, it doesn't write for my case. Usually they will write like how many columns and rows. But never mind, let's just do it in Python for everything. Okay, so I'm going to do to check oops, number of rows and columns in this data set. Okay, so let's try to do diabetes dot underscore data set. Yep, that is this. Then you just type dot shape. Alright, so you run it and you will see there is 768 columns altogether and 9 rows. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that's great. So I also want to describe it to understand better, like what is the count, what is the mean, what is the STD, what is the maximum, minimum of these data, everything. Okay, so let's try to comment first. Maybe I said getting the statistical measures of the data. Okay, so what I'm going to do is just call upon it again. They type it for me. Great. Dot describe. Okay, so it shows to me all this count, the mean, STD, minimum, 25%, 50%, 75% max. Okay, etc. etc. So this is very good. So what I'm going to do next is that I want it to show to me how many of the outcome are diabetic and how many are non-diabetic, right? So basically what I'm going to do is that, okay, let me just okay, just comment it. Okay, then I just do like that. Shows how many diabetes and non-diabetes. Diabetes, that is right, spelling. Diabetes. Okay, great. So what I'm going to do is that I'm going to go that. Oh, okay, great. They even type on me. I love this Google Colab. Okay, so it gives me the outcome because this diabetes data set is showing me the outcome is a 0 and 1, right? For the outcome, it's supposed to be 0 and 1, right? So I'm going to count how many ones are there, how many zeros are there. So I did it value counts and then it will shows me. Great. So 0, that means non-diabetic is 500 and 1 means diabetic is 268, okay, over 768, right? So you can see that non-diabetic has more than those are diabetic. Thank goodness. I hope all the world will be like that. Yeah. All right. The next step. Okay, we know that this is the mean for everything, meaning that the mean for both those diabetic and non-diabetic for pregnancy, as well as mean for glucose for both diabetic and non-diabetic, blood pressure for both diabetes and non-diabetes. So why not we try to separate it, right? Since we already know this outcome of 500 non-diabetic, 100, 268 are diabetic. So let's try to find the mean of those who are non-diabetic and the mean of those who are diabetic, separating it rather than, like all together in one shot, like mean like this. Okay, for glucose is like that. So, okay, let me move on. So what I'm going to do is I'm going to do a diabetes. They're typing for me again, alright? Group by outcome. So the outcome is going to be, yeah, it is really like 0 and 1. So I want to find out the mean for diabetes and non-diabetes. So let's try to run this and you see, yep, great. So it shows me the mean for pregnancies who is non-diabetic is 3.3, for example. For glucose of non-diabetic is 10.9.98, alright, etc. etc. And for diabetes of pregnancy is 4.87, for example, etc. etc. Alright, so good. Now we can actually create further of making the model to be trained, right? But before we train the model, of course we have to make the model to identify which one to train, which one is like the target, which one is the features, this and that. So as you know that the target is the outcome because we want to know whether 0 or 1, whether it's diabetic or non-diabetic, and the features are basically from pregnancies all the way to age. But in this case, we have not informed yet this model because we have not separated it, right? We have not identified it for them to know. So what I'm going to do is that I'm going to separate this data set by target and also the data. Okay, so maybe separating the data and the labels. Okay, so what we're going to do is I'm going to call it as X. X will be all the features. Yeah, great. Alright, it's all the features except for outcome, meaning that everything from pregnancy all the way to outcome, but remove this outcome, drop it, because I just want pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree, function, and age without the outcome. So I'm going to drop the outcome. Okay, so yep, the outcome has been dropped, the column of outcome is dropped, and Y is the target. So what is Y? Outcome. Okay, and I'm going to give the outcome a name called Y. Right now I'm going to run this. Let's see. When you run, right, it's not going to do anything. So if you want to see whether it is understanding it or not, and it's also for your own reference, let's just print X. And you will see what is X. Great. This is X, is all the features from pregnancies all the way to age. How about Y? Let's print Y. Oops. Okay. So instead of having 9 columns, remember we drop the ninth column, which is the outcome, so it becomes 8 columns now. Okay, so let's print Y. We'll see that it's only the outcome, right? So let's see. Yep, good, just only the outcome, whether it's a 1 or a 0. Good, perfect. Now after we have done all this, right, separating between the target and the features, what we have to do next is, of course, before we do the prediction, everything, and evaluation, we need to standardize the data. Okay, as you can see this data set, you can see that this diabetes pedigree function, it is like setting 0.6 something, right? It is basically floating type decimal comparing to the other features, yeah, like glucose, blood pressure, everything else is not in decimal point, it's not float, it's just an integer. And even the huge number, right? For example, insulin has 846 comparing to diabetes pedigree is only like 0.167, even maybe even smaller, I don't know. Okay, it has a lot, right? 700 plus columns, so I don't bother to browse that. And even this one, like the insulin E46, maybe even got more. I don't bother to, browse down. Okay, so there's a need for standardizing so that, let's say, this insulin feature is not going to dominate the others, right? So what I'm going to do is that I'm going to standardize it. Remember, we have uh, import the package of standard scalar over here, right? That's the reason why we import this from SQL and pre-processing, because we have to. do the pre-processing before this evaluation, etc. Okay, so let me make use of the standard scalar. So let's do, maybe I create a text first before that. Okay, so I'm gonna set data standardization. Okay, maybe if you're using Azure platform or Azure, okay, the name of standardization maybe is more known as normalization. Okay, so just not to confuse you, it's actually the same thing. Okay, just in Python we use scalar, so it is all about standardization. Okay, so what I'm going to do is that I'm going to scale the data. Maybe I'm going to create a variable called scalar and use the standard scalar in the libraries. Okay, so just run this. Yep, and then I'm going to make it scalar. Okay, what I'm going to do is, you know, this data has to fit inside, right? So what I'm going to do, okay, I'm going to scalar fit. Okay, scalar not fit x. What I mean by this, okay, this is actually a method used in the feature scaling, commonly used in the libraries in scikit-learn, right? It actually computes the necessary statistic like the mean and the standard deviation for standard scalar, or the minimum and the maximum, like minimum max scalar. But here I'm just going to use the standard scalar because I didn't import the min and max. Okay, I just import the standard scalar, right? This, so I'm going to use this standardization to fit the standard scalar. So basically x is the input data set, okay, which is all the x here, okay, pregnancy all the way to age. Alright, and fit x, actually it calculates the required scaling parameters, but it does not modify the data. Okay, so to actually transform x, you need to transform x or fit transform x. Okay, in this case, I use scalar fit x. So this will compute the mean and the standard deviation for the scalar fit. It will change this. Okay, never mind, when I run this, you can see what I mean. Alright, you can see the difference later on when I run this. Okay, so once I run this, alright, it shows that you're going to use a standard scalar. So let's give a variable because you cannot see what is actually is looking like, right? So I'm going to create a variable so that you can call upon this variable and print this variable for you to see the results. Okay, so let me just name the variable as maybe standardized data. Alright, okay, standardized data and scalar.transform. Okay, so we're going to use this. And remember it's x, which is the feature, and now I'm going to print this. Okay, print this standardized data. Alright, great. Alright, so what happened when I print, can you see that it all changes, right? It all becomes standardized, becomes floating numbers, just like the, what do you call it, the diabetes predictive function, right? Okay, great, so we have done the print test bit. Alright, and the next step is model training. So before I do the model training, there are certain things that I need you to understand. What kind of model training am I going to use? So without further ado, let me explain. Okay, in this video, I'm going to use logistic regression, alright, as well as support vector machine SVM. Okay, let me explain what is this, yeah? Okay, basically, the last video that is about the GDP per capita, if you watch my last video, is I have done linear regression to calculate and predict the GDP per capita in Singapore, right? So in that user cases, it's about predicting continuous value. Okay, so that's why I have used linear regression. Okay, also if you are predicting like house price prediction, sales forecasting, or even temperature forecasting, you can use linear regression. But in this data set, we are predicting whether it is 0 non-diabetic or 1 that is diabetic, right? So it's basically a binary, um, and hence it is, we can use this logistic regression, right? um, okay, multi-class classification also maybe you can use if there is this data set consists of three things, like maybe diabetic or pre-diabetic or non-diabetic, that kind of thing, right? So this logistic regression you can also use for spam detection, medical diagnostics, you know. So yeah, for this tutorial today, for this video today, I'm going to use logistic regression. Okay, just to run to review with all this algorithm. Okay, let's see the decision tree, what it does. If you choose decision tree, it's mainly for combination of both classification and regression. The data set that has classification and regression, right? Such as the customer segmentation, the credit risk, and assessment. Okay, so this data set is not right, so I'm not going to use this. And random forest is basically also combination of classification and regression, and usually it deals with a hard handling with a large data sets. So this is to reduce overfitting. Okay, an example is the fraud detection and recommendation system. Okay, and in this video, apart from using logistic regression, I'm also going to use support vector machine, SVM. Again, this is under classification, not under regression, right? So I'm going to use this also to find the optimal decision boundaries. Okay, that's basically. And then even though it's not for face recognition and sentiment analysis, but for this data set, I want to have a optimal decision boundaries. So I'm going to do two, this logistic regression as well as SVM, and let's see what these differences shall be. Okay, all right. These other things I'm not going to explain because I'm not going to go through all this. Maybe the next video, I do not know if we have the time. All right, so without further ado, let's begin. Okay, so now we can actually train and test the model, but before we train it and test the model, remember we have to split it. Okay, split how many percent you want it to be trained, how many percent you want it to be tested. Just like if we go for examination, right? Before we go for examination, we train ourselves, like to study these notes, study these textbooks, or even do more research. So we spend like 80% doing more study, training ourselves. Okay, then when we took the test, it's like just like maybe 15 to 20% is being tested on what we learn, right? So the same for this machine learning, right? Just like human. So we want to them to know, we have to inform them how many percent you want them to train themselves and how many percent you want them to be tested. Okay, so let me just let me just go to the text. Okay, so what I'm going to say, train, test, split. Okay, I'm going to split the training and the testing part. So the code, I will start with like the features. Remember the features x, right? So x train, x train, comma, x test. Okay, the features is being trained and the features is being tested. Okay, and also the outcome need to be trained and need to be tested. Of course, you test the features, you also need to test and train the outcome so that the machine model knows that, okay, if these are the values of the features, then it should have 1. If these are the values of these features, it should be 0. Okay, so the outcome will also need to be trained and tested, right? So let's y train. It types for me. Okay, I just tap. Okay, let me just move this. Okay, so x train x test, y train y test, and this is just a variable I'm going to call it. Okay, and then train test split. You're going to split the x and the y, where the test size is going to be 20%. You can increase it to 30% or decrease it to 15%, like maybe 0.15, it's up to you. Okay, but if this 20% means that the train will be, it will train for 80%. The training must always be larger than the testing. Okay, just like what I told you about when we study, right? We train ourselves, study more than what we were being tested, right? And then stratify. What stratify means, this is just class distribution consistency. Okay, so when I give this stratify y, meaning that I want this y to be between the training and the test set, I want to ensure that there will be no imbalance issues. Okay, especially when the data is skewed in this case, like I give 80% for training, 20% for testing, right? So still, this will actually improve the model generalization when um, you stratify this. You tell them that please stratify this y, okay? Because this class distribution might not be perfectly like 50-50, but you want to have a consistency between the training and the test sets, even though you give a larger number for testing and a lesser number for training, but you still want it to be stratified, okay? Balancing, to avoid imbalance issues, okay? All right, how about random state 2? Okay, this random state 2, basically, I want it to be, to ensure that it is like it will perform the consistent result. Okay, like when sometimes if we don't give this random state, maybe it will run randomly, like maybe it will run sometimes 3 times or 4 times. Okay, but you give a fixed number of 2, so whenever they perform the operations, they will always split the split data and model initialization to 2. Okay, so that's what I mean. Okay, so it's good that you give this random state and stratify, right? So this is just a good example that you should put into practice, right? So yep, I hope you understand what I mean. Okay, so let's run this. All right, so there's no error. Now once you have done this, then let's try to print the x and the y to see, print the x dot shape to know that. Okay, just type for me so we could. X shape means this is the original data shape. Okay, how much the columns and row that will be in this data set, and how much of the features of x will be trained and test. Okay, it means the columns as well as the rows, right? All right, and how much will be tested also. Okay, so let's run this. Yeah, it shows me, the data set has 768 columns and 8 rows, because we drop off already the outcome, right? So you will train 614 from the 768. I will train all the columns, all the rows, sorry. And for the test, it will train 154 um, the the what do you call it, the columns, and all the rows also except for the outcome will be tested. Okay, so this is good, perfect. Now once you have done the splitting, okay, we also have done the standardization. Yep, we are good to go. We can now actually train the model. Alright, so let's train the model. Okay, so let me just give a text here. Train the model. Whoops. Train the model. Okay, so let's see the code. Okay, so again, I'm going to do, because this is a logistic regression, right? Between binary 1 or 0. It's not linear regression, yeah? It's not a continuous values. So we're going to use logistic regression. Let's say I'm going to use classifier. I'm going to name it as classifier logistic, maybe, or just classifier logistic, or LR, logistic regression. Okay, I'm just going to name it as classifier logistic LR, Okay, and then I'm going to set, yeah, this is what you're going to do, logistic regression. Okay, so I'm going to run this, and what I'm going to do after I told that we're going to use the logistic regression for this model, definitely we're going to train this model using this logistic regression, right? So to make it fit, we use it classifier, oops, classifier LR, fire LR. You're gonna fit this X train and Y train, okay? So what I'm gonna run is, yeah, it's going to run this logistic regression, and now I'm going to like see the accuracy after it has run, right? You have to see the accuracy score on the training data as well as the test data. So let me try to do it, like find the accuracy score on the training data. Okay, oops, training data. Okay, so how I'm gonna do that is like x underscore train train prediction. Yep, they type for me, that's great. Okay, so you're going to x train prediction for the class LR that we have classified. I mean we have name it here, right? The variable as classify LR dot predict. You're gonna x train, and I'm gonna give okay, they type it for me, great, so I'm just going to make use of it. Training data accuracy is the variable. You're going to see how much is the accuracy score, okay, but it will not show me, but so later on I will try to print it, okay. So maybe I just type here print training, yeah, data accuracy here. Okay, so let's try to print. Yep, it's 0.785, not bad, yeah. Of course, if the value goes to number 1, which is the highest, which is the perfect score, but I guess even us, we cannot score 100% for every examination, right? So the simple machine learning also, they try to train also. We cannot like make them to train and get 100% in every time of their training. So 0.78 is good enough. Okay, it's considered 0.8 if you round off, right? So this is a good score. All right, and now we are satisfied with the training. Let's do the testing and check the accuracy also. So let's see accuracy score on the testing data. Okay, so similar. Okay, but instead of training we said testing. It's actually similar lah. So it's not too hard. Okay, just change the name so that you will not, be confused. Same thing can of course have the different same name for individual, right? So this is test, and instead of x train you just change it to x test. Okay, then testing, you're going to do the prediction of, instead of y train you're going to choose the y test, then you print testing data accuracy. So this one is not bad, 0.759, which is yep, at least it's more than 0.5. Yeah, because the best value is 1, but definitely even us we cannot achieve 100%. So yeah, machine learning also, all right, is very hardly that they can achieve 100%. So this is good. Okay, so now let's make the final task, which is making the making a predictive system. Okay, what I mean by that is, let's say a doctor or a nurse, right, type in the patient's the patient's pregnancy value, glucose value, blood pressure, whatever, and age, and then the machine learning will showcase the outcome whether this person is diabetic or non-diabetic. Okay, so that's what we're going to do. All right, so okay, before that I need to make what do you call it, yeah, to definitely like, you know um copy all these things, right? The features. Let me see. Yeah, this is the features I need to paste. Copy. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay. All this. Okay. Until here. Control C. Okay. So. Okay. I'll give a prompt for the doctor or nurses to like. Is she pregnant? What's the glucose level? Okay. Blood pressure. Okay, so they know what they are inputting lah, basically. Okay, sometimes too much to input also we forget, right? So yeah, this is just the prompt that I'm going to be creating. So age all this. All right. Okay, for example, right, like pregnancy is equals to, let's say the input is whether a yes or no. Okay, but in this case, right, there's no yes or no, so to follow in it's like just like numerical numbers, so it's an integer, right? So I'm just going to put here integer. Okay, and maybe pregnancy, pregnant, pregnancy, pregnancy. Okay, so maybe I can set like 0 for 0 to 17. Maybe there's until 0 for to 17 this Excel sheet. I'm not sure, just follow lah, huh? Okay, then glucose, the same thing. Yeah, did it for me because glucose also is in integer, I believe. Yeah, yeah, but okay, so just leave it to integer. So integer, and then yeah, maybe 0 to 200. Then blood sugar, blood glucose is okay. Alright, just follows on. I just tap right integer, integer. Skin thickness 0 to 99, integer. Wait, skin thickness, I forget to put equal sign. Okay, equals to integer also. Oops. Okay, insulin. Okay, just give a number. Okay, sorry about this because I've done this before, so it's like automatic. Okay, so let's remove this. Oops, so diabetes pedigree I didn't do it. Okay, so float and then age. Let me count 1, 2, 3, 4, 5, 6, 7, 8. Yeah, perfect. Okay, so maybe there's no one in Singapore live until 81, right? I don't know. Okay, you can increase whatever. Okay, so if I want to run this, right? Oops. Perhaps we forget a comma. Skin thickness. The integer input. Did I? Equals to which comma? This close bracket, not comma. Okay, so let's try to run. Hey, also this one, yep. Close bracket. That means this is a close bracket. Yeah, I didn't check. Yeah, this one is a, as you can see, there's a red color means something is strong now. Okay, so this one is fine. There's no red color. So let's try to run. Yeah, okay. So let's say pregnancy. Maybe they put 6. Okay. Glucose level I do not know. 100 perhaps. Blood pressure maybe okay lah 50, 55, whatever. Skin thickness 20. Insulin maybe 500. BMI 32.1 for example. I don't even know this number. Okay, just start anyhow. Okay, so maybe 1.2. Okay, age maybe 32. Okay, let's see. Alright, so great. It's working, yeah. So we have done this, and of course, once the nurses or the doctor has start in this information, right? The machine learning should tell whether this person, these values all will make the person to be diabetic or non-diabetic. So how we do that, right? So first we have to somehow like standardize this input data because this input data is not standardized, right? And in the machine learning, remember I told you that we need to standardize these figures all to be like that, right? To scale it, right? So let's standardize it. So just put standardize standardized the input data. Okay, so yep, how to do it? Just I name it as std last standard data instead of standard country was that std. Okay, since the type form is standard. Okay, standard data. Okay, I don't need to be the same as just now, so maybe I just make it a bit different now. Maybe std data. std data. Okay, standard data. Equals to scalar dot transform. Okay, so you have to transform all these the input data, right? And all this input data is the pregnancy, right? Pregnant. Yeah, they type for me everything great. Okay, all these the things that I ask the nurses or doctor to type in, right? It has to be standardized. Okay, and then now we can okay, let me run this. Okay, pregnancy. Oh, what is the problem? Maybe it's because yeah, this is an array, right? So yeah, so much already. So what I'm going to do, right? Maybe first and foremost, I make all this into I convert all this into an array first, right? So okay, let me just okay, hold on. Maybe I make another code on top because I don't want to redo this. So maybe I create an array with the input values. Okay, so we already have a numpy, so that we already in the very beginning, right, we import numpy as np, so we can make use of that. So okay, great, input data is equal to parentheses. Okay, so I'm going to change this into np array. Okay, where I'm going to give, of course, this is an array, so you have to have this kind of bracket and close the bracket here. Okay, so yep, let me try to run this, see if it works. Yep, it works. Okay, so now you can standardize the data, okay, by calling the data, which is you know this is really converted to array, right? So instead of calling all this again, I will just transform this input data, okay, which is this part here, input data. So let's try to run. Oops, what is that? P input, sorry, input data. Still wrong. Hey, that was a problem. Scalar dot transform input data std data. std data is going to scalar dot transform. It should be correct, yeah. What's the problem? Okay, let's check the first one. np dot array. Okay, I need another bracket here. Sorry about that. Okay, so yep, it's supposed to be like that. Okay, and let's try to run this and try to run this. Yep, this is fine. Okay, so don't care about the warning. It's just I should have declared in the very first beginning, that like the first video, right? To ignore warning. Okay, warning is not very important. This one, okay, in this case. So what's next? Then we can make the prediction, right? So okay, so let's make the prediction. Make a prediction. Okay, so prediction is based on what we have just now trained the model, right? Yep. Whether you want to use the linear regression or I want to use the SVM. So I think I want to use the SVM because it's more accurate lah, a little bit more accurate, right? So I name the SVM is SVM, yeah, like that, right? So okay, I'm going to make use of this SVM that I've done just now, right? So, yep, okay, and yeah, okay, so let's try to run this. Okay, perfect, now it's working. So now let's display the result because you just run without displaying, so you cannot show anything. Yeah, so display the result, and then what we're gonna do if prediction oh okay, the type for me of gone. And then my if prediction is 0, then okay, if the array is like 0 equals to 0, right, that means if the prediction in that array, right, is in all this after calculating all these features inside this array, okay, so I put the bracket here, okay, is equal to 0, then I want it to print, let me doing this 0, this one, okay, yep. Then I want it to print maybe this person is not diabetic, okay, else you print this person is diabetic. Okay, always my H is high. I don't know why. This person is diabetic. Alright, great. So let's see. Let's try the diabetic eye as well. Okay, so let's try to run. Oh, okay. So when you type here, right, this person is not diabetic. Okay, let's try to run all over and see whether it really works. Okay, so I just want to follow this data set because I'm not a doctor or nurses, so I still do not know the value of what. Okay, just let me try just this first one. Okay, so the pregnancy is 6. Okay, and then if I were to type exactly the same, right, it should give me the outcome, which is yes, the person is diabetic. Okay, so glucose is 148, 148, enter. So what's next? Blood pressure is 72. Okay, next. Then skin thickness is 35, insulin is 0. Okay, 35, insulin 0. What else? Enter. BMI is 33.6. I want to exactly, right? So I don't want like because it's type is like that. You train the data set to follow onto this, right? So I want to type exactly and see whether it's showing diabetic or non-diabetic, okay? Whether it's correct or not, alright? 0.627, 0.627, enter. And then the next one is, what is this age? Oh, 50 years old. Okay, 50 years old. Alright, so when it's printed, it says this person is diabetic. Yay, great. Yeah, this person is diabetic. Alright, hooray, it works. Alright, so basically if you follow on to whatever number here, right, it should exactly follows on. It means your data set has trained properly, accurately of this percentage just now, right? 7.9 lah, okay, and test also for 0.77% correctly. So if let's say the person type in a little bit different from whatever is in the data set, it will still learn the pattern and it will still try to predict whether the person is diabetic or non-diabetic. Alright, cool, right? So congratulations, you completed this video and I hope you really enjoy it and you really learn something. So if you do, please subscribe and like the button and share. Thank you so much. Have a nice day, guys.